Have you ever really stopped to think about what's going on inside your phone, or your watch, or your laptop? There are these tiny, invisible brains in there, working at speeds that are just impossible to imagine. They're the engines of our entire modern world, but they're so small we never even see them. So today, we're going to go on an incredible journey of miniaturization to find out how in the world we squeeze the power of a giant into the palm of our hand.
All right, so check this out. On the left, you've got the guts of a fitness tracker. On the right, an iPhone motherboard. And you see all those little green boards and silver lines? It's like this intricate little city map, right? But the real magic, the real action, that's happening in those little black squares. Those are the brains, the command centers of the whole operation. So what on earth are these things?
Well, those are what we call microprocessors. And the idea is actually kind of simple, but totally brilliant. It's a central processing unit, a CPU, the entire thinking part of a computer, squeezed onto one single, tiny chip. A whole city of billions of microscopic switches all working in perfect harmony. But to really truly get how amazing this little chip is, we gotta rewind. Way back.
And I mean way back.
Back to a time when computers weren't pocket-sized.
Nope, they were absolute giants.
So, say hello to the ENIAC. This was built back in the 1940s. It was one of the very first electronic computers ever made. And yeah, as you can probably tell, this thing wasn't exactly portable. It took up a whole room, and programming it, forget typing. You had to physically unplug and replug this crazy, tangled mess of cables.
And just to give you a sense of the scale here, this thing weighed 27 tons. Seriously, that's like 4 full-grown elephants. Just try sticking that in your backpack to check your email. So what was inside this monster? A crazy jumble of almost 18,000 vacuum tubes, which, are basically just fragile glass light bulbs acting as on-off switches, and tens of thousands of other parts. And the power it sucked up? Whoa. Enough to light up a whole neighborhood. It was an absolute beast.
But you know what the real killer was? It was totally unreliable. I mean, with that many delicate hot glass tubes, something was always going to pop. On average, this thing would fail every 6 hours. Everything would just stop. So yeah, computing was powerful, but it was also huge, it was hot, and it was a mechanical nightmare. Something had to change, and fast.
And that change, that solution, it didn't happen all at once. It came in 3 giant leaps. 3 revolutionary inventions that would take that room-sized monster and shrink it down, changing our world forever. So here's the roadmap. In 47, we get the replacement for the vacuum tube. Then in 59, we figure out how to put a bunch of stuff on a single piece of material. And that all leads to 1971, the grand finale, the first computer brain on a single chip.
All right, leap number 1. It all starts with getting rid of that clunky, fragile, power-guzzling vacuum tube.
And here it is. I know, it doesn't look like much, right? Kinda like some scrap from a workshop. But what you're looking at is one of the single most important inventions of the entire 20th century. This is the very first transistor. It did the exact same job as a vacuum tube. It was an on-off switch, but it was solid, it barely used any power, and best of all, it was super, super reliable.
Now, the story behind it is pure drama. The guy leading the team was William Shockley, but apparently he was, let's just say, difficult to work for. So difficult that 8 of his top engineers, including these 2 names you're going to want to remember, Bob Noyce and Gordon Moore, just up and left. They were called the Traitorous 8, and they went on to found a company called Fairchild Semiconductor. And with that move, they basically invented the whole Silicon Valley startup scene.
Okay, so now we have the transistor, a much better switch. But there's still a huge problem. You still had to wire thousands of these things together by hand. The next big challenge? Getting rid of all those messy wires.
And this was the brilliant solution. This is the first integrated circuit, the IC, the absolute genius move, which was co-invented by Jack Kilby at Texas Instruments and our guy Bob Noyce over at Fairchild, was to build all the parts you need, the transistors, the resistors, everything, from one single solid piece of material. No more wires. This is the moment the chip, as we know it, was born.
And remember our rebels Noyce and Moore? Well, they were at it again. In 1968, they left the company they founded, Fairchild, to start another one. A little company you just might have heard of, called Intel.
Okay, this is it. The final incredible leap. We've got the switch, the transistor. We've got the method for putting lots of them together, the integrated circuit. There was just one thing left to do. Put the entire brain of a computer onto one single chip. And would you look at that, the Intel 404. In 1971, Noyce & Moore's new company, Intel, released it. This was it, the world's first microprocessor. A whole CPU on a tiny sliver of silicon. Seriously, every single smart device you own has a direct family line going all the way back to this little guy right here.
And once the microprocessor was out there, boom, the floodgates just burst open. The slow crawl of computing progress suddenly turned into an absolute explosion of power and shrinking technology.
And this right here, this is the payoff. This shows you just how far we came and how fast. In only 25 years, we went from ENIAC, the 27-ton room filler, to the Intel 4004, a chip you could lose in your pocket lint. Now get ready for this, because this is the truly mind-blowing part. They both had about the same amount of processing power. Just let that sink in for a second. And you know what? The shrinking didn't stop there. Not even close. Okay, think about a single human hair. The transistors on that first Intel chip were already 10 times smaller than that. Flash forward to the Pentium 4, and they're way smaller still. But today? Today's chips have transistors just 10 nanometers wide. We're talking 10,000 times smaller than a human hair. It's just staggering.
So, after all that incredible history, we've come full circle, right back to the powerful little brains inside the devices we can't live without.
And this image just says it all, doesn't it? On the left, where it all started, the giant ENIAC, and on the right, a processor from a smartphone. That tiny little square isn't just as powerful as the giant machine on the left, it's literally millions of times more powerful. It's almost impossible to wrap your head around.
At the end of the day, this incredible story, from the glass tube to the transistor, from the integrated circuit to the microprocessor, that's the reason our world looks the way it does today. It's why you have a supercomputer in your pocket.
And all this leaves us with one huge question, right? For over 50 years, progress has meant one thing: make the transistors smaller. But we're getting to the point where you literally can't make them any smaller. We're running up against the laws of physics. So, what happens when we hit that wall? What's the next great leap